Well, thank you very much for having me. This is a fun topic when I enjoy discussing because it's really all about our code and how good it can be and how awful it can be and all the various hacks and crazy ways that we do things to try to fix performance problems. So there's gonna be good things, there's gonna be some bad things, there's gonna be some weird things, and I'm gonna present all of it. So when you see me put a slide up or talk about something, don't immediately assume good or bad. It may be either. And I'll switch it up a lot because there's all sorts of fun things out there. There's way more than I can even have time to present now. So this is all about parameter sniffing. What is it? What do you do with it? I'm going to start off very basic and get more advanced. But before we do any of that, I'm going to find my mouse pointer because it vanished. And here's me. I've done a lot of stuff in the SQL world. I've published some books, lots of articles. I've spoken at many events. There's my SQL Saturday umbrella from an event like 7 years ago, back when we gave out swag at events. I really do miss that. The umbrellas were great. Mine broke last year. But anyway, feel free to find me on Twitter. Any questions, message me, feedback. Do I talk too fast, too slow? Too slow. But anything like that, just anything you want to talk about, feel free to contact me. I love chatting about data. I enjoy it. People all the time tell me things I didn't know or provide useful feedback or just have a laugh. Any of those things are great. With that, I'm going to jump right on in because you're not here to hear about me. You're here to hear about parameter sniffing. Here's what we're going to do. We're going to do a whole bunch of really fast review. It gets faster, yes. Plan cache, plan reuse, and parameter sniffing. All those definitions, what they are, how they work. I'm going to kind of zip through that quickly, kind of assuming you may know it already or at least could benefit from a quick review. Once we've done that, the rest of this time will be spent on how do you resolve this crazy thing called parameter sniffing. What are good solutions, bad solutions? What are the patterns and anti-patterns and all of the good and bad things people do? We'll talk about as much as we can and then some. If you have questions along the way, feel free to put them in the chat and I will get interrupted happily and I will discuss them. And if they're too long and complicated, we'll chat about them later. No problem. At the end, we'll wrap up questions, jokes, discussion, whatever you want. Again, does not need to be me talking for 90 minutes. That's boring and will put us all to sleep. I'd love to be interrupted a little bit to chat, hear stories, whatever. It's not a problem at all. Questions are great. I love questions. So with that, let's jump right into the most simplest of simple things to talk about query processing in SQL Server. Every database engine executes queries through some process of steps. In SQL Server, there's 4 steps of which we're going to really focus on one of them. First step in processing a query is you parse it. This is all about syntax. Are your syntax keywords spelled right? Do they all make sense? Is the semicolon where it's supposed to be and the spacing and whatever? If it is, great. If it's not, you get an error message immediately saying something's wrong, error at some place in your code. Parsing is about syntax. It's pretty straightforward. You do it right, great. You do it wrong, you get a bunch of red back. That's parsing. Binding is the next step. If your syntax is all correct, SQL Server now says, all right, you get a query. I know what you're trying to do. Let's check all the objects though and make sure they exist and they're correct. If you're referencing tables or stored procedures or views or functions, it's going to check all the inputs and outputs and the columns and everything else in there and make sure that you've done everything correctly. If all the names match and you didn't misspell a column or something like that, great, you go on to the next step. If you misspelled something or got the wrong data type for something or just somehow mucked up your names of your objects, the object's not found, you get a red error message immediately and nothing happens. So in these first 2 steps, if you mess up, you immediately get an error back saying you messed up. If you succeed, you keep going. Great. The third step in query processing is optimization. You now have a query, we know what objects we're working on. We've got to now take that and turn it into an execution plan. An execution plan tells SQL Server what to do. How does it process the query from start to finish? Optimization is a big, complicated process. It's not simple. It involves taking and guessing at all these different plans and running them through and getting query costs. It's expensive. It costs CPU. It costs memory. It takes time. That's what we're going to be talking about today is the optimization step. The execution step, while not simple, is pretty straightforward. It just follows the instructions from optimization. So you parse your query, you bind your query, you get an execution plan, and then you execute it and follow those directions. That is how a query is processed in SQL Server. The rest of the session is devoted to optimization. Other steps are important, but not to the session so much. So we're not going to talk about them again. What is an execution plan? It's all it really is at the end of the day is a set of steps. They're instructions. They simply tell SQL Server how to do what it has to do. And that's it. They're executed from right to left. And so you start on the right and you have things like seeks and scans and lookups, and you're grabbing data out of tables. And then you join it all together, and all the way on the left, you get your results, your select, your update, your delete, whatever. Each step is called an operator. There can be a simple one like the one pictured here. It could be complicated. It could have hundreds of steps in it. Those aren't that uncommon. You can write a big complicated query with lots of steps, or a simple query with less steps. That's all an execution plan is. It tells SQL Server what to do. It's instructions, and that's it.
We've got your very first question, sorry to interrupt, from Tom Wickereth. So when one uses SSMS, is there a form of binding prior to running a SQL statement? I ask because one oftentimes sees the squiggly line indicating an error.
That is a great question, and the squiggly lines will occasionally lie at you. If you want to, there's a check mark. You can highlight a query, hit the check mark in SQL Server, and it will basically check and parse it for you. It will not do binding, but it will parse and check your syntax. So if your syntax is valid, that check mark there will do the work for you. There's no way to do binding ahead of time, but you can always just run your query and see what happens. You could do an estimated execution plan if you'd like. The estimated execution plan and the process of calculating it and doing the work will not execute the query, but it will have to bind in order to get the estimated execution plan. And therefore, if you have a mistake in your binding, you spelled something wrong, it will throw back an error. I would also say test in dev as well, anything you're doing. But if it does fail in binding, it's no big deal. Squiggly lines come from two places. They come from Management Studio. You could potentially be in the wrong database currently and haven't seen something yet. So squiggly lines sometimes lie. Some tools that you may have like installed tools in Management Studio, like Redgate SQL, prompt other tools. Oh, if you change from sales.orders to sales.order, yes. The squiggly lines will typically tell you of a binding issue, that some object doesn't exist or something is wrong. It's not 100%, but it's usually a very helpful thing. I'll keep going from here, but if you have more thoughts on binding, let me know. This is really a session about optimization, so I don't want to go too far into binding, though that is important. And squiggly lines do make me cranky in everything, like spell check too. Is it doing? Yes. So when you see squiggly lines in Management Studio, that is IntelliSense automatically checking objects for you and querying system views to see if you're doing things correctly or not. So yes. Someone else already said that. Great. You're all answering your own questions. This is lovely. Awesome. I'm going to keep going, but that was a good question. That is a very useful feature. I do like it a lot. So we know what an execution plan is. What does the optimizer do? The query optimizer is a very complicated piece of software. I'm not going to try to make this simple. It is complicated. It's proprietary software in the SQL Server world. Other database engines have their own forms of the query optimizer. They basically take information about your tables and objects, like statistics and constraints and indexes and so on, and metadata, and will take all that information to put together an execution plan. And it won't just get an execution plan, though. It can't just do that. That's too simple. It's not going to work. It's going to go through and generate a big list of plans and say, all right, I'm going to get a whole big long list of possible plans that might be good. And then we're going to score them all. I'm going to assign query costs to them. If you ever look at an execution plan and see estimated query costs, that doesn't have a unit. That query cost is just query cost. It is a kind of a comparative number that helps you gauge the difference between different queries and their execution plans. So if you have a single query and you have 10 execution plans, one has a query cost of 1 and one has a query cost of 10. In theory, the one that has a query cost of 10 is 10 times more expensive to run in theory, but that isn't always the case, though. That's just really how SQL Server scores them based on things like stats. It assigns a cost. It evaluates as many plans as it can in a very small period of time to arrive at kind of the best plan possible. SQL Server may not always choose the best plan because there's just too many out there, but it will take a bunch, it will score them, it will get the best one possible, and then continue from there. It will usually get a good plan. This is a sort of thing that's very often correct, very rarely incorrect. It can be incorrect, but not that often. The best way to think of the query optimizer is it's kind of like a chess AI. It has to go through you move your pawn up, and the computer now has to evaluate every possible move going out into the future to figure out, how do I defeat Ed in a game of chess? It'll make a move. I'll make a move. Then it has to think some more. The big challenge for the query optimizer is going to make those decisions very quickly. You can't wait 10 minutes for the optimizer to pick the best plan. You don't have 10 minutes to wait. You're in an application, you're doing something, you're clicking a button. You're not going to wait more than a few milliseconds. So the optimizer is going to work very fast. But the key to the optimizer is that it's expensive. It takes a lot of CPU, it takes a lot of effort by SQL Server to get a plan. And the more complex the query, the more complex the optimization process, and the more complex the plan, and the harder it is to get the best plan. And those are all very key elements to when we're writing queries and writing stored procedures and functions and writing code, is that more complex means more complex, and that complexity will trickle right on down through that whole execution process. So really quick, for the sake of what we'll be seeing here today, here's a very simple query. I'll be using similar queries throughout this entire session. I'm not introducing crazy complicated ones because it's not really necessary for the purpose of this. Here's a very simple query. I'm in an application, I'm searching for an order. I'm the customer, I put in my customer information, it gets me back all my orders. I run this query, I get results. I clicked up here earlier to include the actual execution plan. You can also do the estimated as well. They'll usually be the same, but sometimes they might be different. If they are different, that's a very great place to start for trying to figure out why something might be wrong. But here's my results. I get my IO back as well. IO is very useful. Set statistics IO on, gives me an idea of IO. IO doesn't tell the whole story, but it is useful knowing how many reads you have against tables. For the purposes of our conversations today, I'll reference these occasionally, and logical reads is done in pages. So a logical read is 8 kilobytes, one page. So 259 reads is 259 times 8 kilobytes, whatever that turns out to be, reads. I click over here, I see my execution plan. My execution plan tells me I did a seek off of an index, great. I did a key lookup because there was at least one column that wasn't in the index. It joined it all back together and spat back some results. Great. That's an execution plan. It's read from right to left, and you can hover over any step or any line and get a whole bunch of information, and that is very useful. Great. Execution plans are expensive though, and to optimize a query over and over and over, especially for a very busy application, you might be having queries pop through millions of times, tens of million times, hundreds of million times or more a day. You can't optimize over and over and over. You would just destroy your machine. It will be very expensive. It will cost a massive amount of CPU time that you just don't want to spend the compute on it. So there's a construct called the plan cache. The plan cache is stored in memory, and it is a place where plans go to live for a while. So basically you execute a query, you get an execution plan, that plan gets stored in the cache. Whenever a query comes along again with the same text as that previous query, instead of optimizing it and paying a bunch of CPU and time, it goes right to the cache, uses the query plan query plan that already exists, and off we go. And it saves resources, it's fast, and it's wonderful, and it's automatic. Again, this whole thing is in memory, which means that if you restart your SQL Server, it all goes away, which isn't really a bad thing, but it is worth noting. Plans don't stay in cache forever. There are many reasons that plans will age out. The primary reasons are time. If a plan has been in cache for a very, very long time, it can age out. If there are schema changes, a plan may get removed. If I alter a table and change column definitions, that plan won't be applicable anymore, so it'll go away. A big reason is memory pressure. If your server has memory pressure, plans can age out for that reason. If you have a couple of gigs available and you're just slamming your computer with tons of stuff and your server's running out of RAM, it's going to begin cycling plans through and getting rid of the old ones and putting new ones in. And if there's a lot of memory pressure, you'll just keep cycling things through, which is actually bad. You want plans to stay in cache for a long time so they can get reused. If they're getting dumped and replaced constantly, you're making your SQL Server work really hard for no good reason. The key to the plan cache, it's managed automatically. There are tweaks you can make in SQL Server to adjust how it works, but in general, you let it alone because Microsoft has spent many years working on the optimizer and making it smart. And unless you know better than the optimizer, you generally don't muck with it very much. Just general good advice, don't mess with it unless you know what you're doing. A key to these plans, though, is that the query text is exact. If you change the text slightly, even just put a space in there or a comment, or you change a literal, a capital letter, you'll get a new plan. That sounds crazy, but in most applications, queries get reused over and over and over. And so that idea of it getting a new plan, it isn't so weird. So the plan cache is a place where query plans go to stay and get reused and save lots and lots of resources. It's important. It's a very important piece of SQL Server. All these I'm going to make available afterwards. I'll post it all on Twitter, my slide deck, as well as all these queries in case you want to steal anything from me. Before we continue, I'm gonna run this very often, either free proc cache, or I'm going to clear the cache from my database specifically that I'm in. Never run these in production, please. Even in a dev environment, make sure no devs are gonna get mad at you. But this will clear out your plan cache. Great for testing. Don't ever do it in production if you like your job, though, because you will cause problems that obviously get optimized again. This is the same thing, but I can do it for one database. Very useful. You can remove individual plan handles as well if you want. Make it really detailed. For the sake of what I'm doing here, I'm going to use a sledgehammer because no one else is using my local server except for me, so I can beat on it all I want. Here's our query from earlier. I run it one time on an empty cache. I get back my results. I have a query execution plan. I have IO. I have all this information. This next query here, I'm not going to really explain how it works. You can steal it from me if you'd like and reuse it. There's many variants of it out there on the internet. Basically, I'm going out and getting execution plan details, including the XML plan, the SQL text, and some stats. And I have some filters here so I don't get too much junk back, no system stuff. I run this and look at that. That was funny. Okay, what did I do? This is not cool. There we go. I don't know why I was filtering it out. So here is what's in my execution plan right now, execution plan cache right now. I realized that this query up here included the text from it. So I'm just going to get rid of this for now. I'm just going to comment it out because things change.
While you're just commenting that out,
sure.
We had another question from Rick. So is there some advantage to prefixing the column name with the table name? For example, orders.ordersDate when there is only one table in the query?
Great question. It's 100% style. You do not have to prefix it if you do not want to. I often do it as a habit of style. I tend to prefix and alias everything with the table name, or if I need to, an alias. It's 100% a preference. It won't impact your performance whatsoever, though. So if you have your own style, feel free to implement your own style. It's cool. And is the code going to be available later? Yes, I will post all this on Twitter as soon as it's over. And if the GroupBy folk would like to have it as well, I'll give it to you as well.
Awesome. Thank you.
So I'm going to run my query a few times, and I'll go to the cache and take a peek. And what you'll see here is here's my cache plan. There's the text of my plan of my query, exact text as I ran it over and over. It was executed 3 times, so it got reused a few times. I have the totals for a whole bunch of stuff like reads and writes and worker time. Really useful stuff. Last execution time and, hey, execution plan. So you can query dynamic management views in SQL Server and get back a whole bunch of details and kind of view what's in the cache. It's a very useful query. You can customize this heavily and get what you want out of it at will. It's really up to you. But this is where the query plans are. We're going to use a query like this for the rest of the session to look at the contents of the cache, understand what's in there, and how changes we make impact them. Now, let's say I run the query now for different values of customer ID, like 1018, 1020, -1. And then I go and I look at my cache. I will now see more queries there because, again, the literal text changed. The actual query text is changed. These are all different queries to the optimizer. 1015, 1018, 1020, -1. There's no -1, but still, it gets cached anyway. It's an empty set, right? I return nothing, but there you go. So I now see a whole bunch of individual plans in here on my local server, and they might be different depending on the values. I could have gotten a different plan for each one. Might have gotten the same plan. So this is really what I'm going to use for the rest of the session to talk about the plan cache, is that this is where plans are. They stored here, they stay here, and this is a valuable feature that we want to take advantage of. If you had the SSMS option for ad hoc queries, that might have caused your first execution to not show up in your query. That is true. I do not believe I have that enabled. I think I just have a local server with very little memory on it. That's all. I'll execute things quicker and not be as careless with my text. Not a big deal, but thank you. I do appreciate the feedback. That is important. Settings Management Studio do impact how things look. And if you have bad Settings Management Studio, makes for weird demos. The next step in our journey through here is parameterization. So one of the things that I illustrated is that you have queries with different values and they all got different execution plans. Well, that's not good. If I have a busy application where people are logging in and searching for things all day long, I don't want a new plan for every order or every customer or for every contact. I want one execution plan reused over and over and over, right? That's ideal. That's where parameterization comes in. You can parameterize stored procedures. It's straightforward. You have parameters defined in your stored procedure, and then they get used in the proc. And an execution plan will now get generated for that whole proc and used regardless of the parameter values. This is a really important piece to really how the plan cache works. It's important, it's a feature. This is not a bug, this is a feature. Ultimately, for a plan reuse to work, you need parameterization. You need a stored procedure that's executed 1,000,000 times to use the same execution plan most of the time, not use a different one 1,000,000 times. If you're recompiling your query over and over and over to get a new execution plan, SQL Server is paying a huge price for that. It's very expensive. We don't want to do that. So parameterization is very important. So if I have a very important query that I want to run, I should not run it ad hoc like this over and over and over. It's okay, but if I was doing this 1,000,000 times an hour, 1,000,000,000 times a day, whatever, it's going to get really expensive. My server is going to work hard for no reason. And on top of that, I'm going to fill the plan cache up with lots and lots and lots of plans. And that's not really what I want. I'm making the whole thing inefficient. So I make a stored procedure. We'll just clear out my cache. And I'll create a stored procedure called get customer order details. I pass in a customer ID, I get back my results. You may say, hey, why would I create a proc with a simple query? The answer here would be to parameterize it. And so now I can get a single execution plan for this proc, and that plan can get used over and over. I can now go ahead, I can execute the proc. Maybe I'll execute it a few times. Execute it, execute it, execute it. And then I'll go here, and there's my plan. And I can see that it got used a bunch of times. But note, in the text of the plan, I have customer ID there. The proc definition is in there. And so it's recognized as an execution plan for the stored procedure, not for my query, for the proc. Now, if I go back in and I run the proc a whole bunch of, doing bad things here. Sorry, I ran a whole bunch of stuff. If I just execute this proc over and over a bunch of times, and then I go in and I check and say, hey, give me back my results, I'll see now that I have a variety of stuff here, but I have one plan for my stored procedure that ran 31 times. And that's what I want. I want to be able to search for 1015, 1016, 1018, -1, 99999, pi e, whatever. Like I should be able to search for whatever customer ID I want and get back the same plan over and over and over, reuse it, done. This is ideal. This is a busy server with an application on it running queries constantly all day. I want this to be thousands, millions. That's perfect. That means that I'm not optimizing it 1,000,000 times. I'm just reusing the plan. And that's efficient. That's what we want. So finally, once we talked about parameterization, we can talk about parameter sniffing. This is the whole topic for the session. Let's dive into parameter sniffing. We have plans that are stored in cache. When you run that proc for the first time, it will generate a plan based on the parameter you passed in, that parameter value. So whatever the first parameter value supplied was, that becomes your execution plan. But it's possible that plan may not be optimal for all parameter values. Sometimes I may run in a value that returns 1 row. Other times might return 1,000 rows or joins in different ways. This is a side effect of plan reuse. And it's important to note that parameter sniffing is not a bug. It is not an evil. You should not forwardly go out to avoid it everywhere and get rid of plan reuse. In general, this is what you want. We use parameter sniffing as kind of a naughty word, but parameter sniffing is good, plan reuse is good. In general, you want plans to get reused as much as possible, and only when bad things happen should you respond to them. We shouldn't actively go out and avoid plan reuse. That's generally going to cause more trouble than it's worth. So the key here is that parameter sniffing is a feature, not a bug, and we want this to work correctly. So I demoed how a proc works for this. We're going to clear up our proc cache some more. I'm going to put an index in place. I ran it before because I hit F5 before. It's fine, it's already there, no biggie. So now I go ahead and I run this proc for a very narrow date range. Again, all I'm doing here is I'm searching for orders for a date range. These are not complicated queries. I'm keeping them simple on purpose. So my date range here is a very small date range. My execution plan here is a seek and a key lookup, which makes sense. Very, very narrow seek, small range of rows, do a seek against an index, done. Let's say that I went ahead and I ran it for a big range, such as several years worth of orders. That returns a lot of rows, tens of thousands, and it does an index scan. Sometimes you may be led to believe that all scans are bad, but this is a case when a scan is good. I'm returning a good chunk of the table, therefore index scan makes sense. And so for this specific set of parameters, a big wide range of dates, lots of orders, the clustered index scan is the right choice. So for the narrow range of dates, a seek is great. For a big wide range, a scan is great. Now, what happens if I were to run it for the narrow range and then immediately the big range? I'll see that I got an index seek. And that isn't really what I want. In fact, I got back 140,000 reads to execute that query. Now keep in mind, this table isn't that big. This table isn't gigs. That's a lot of reads. If I clear the cache and run it, and I use the scan, it takes less IO, because it turns out traversing a binary tree and going to every single leaf node and every node and grabbing back every single one of my rows one by one by one by one by one by one 45,000 times is much more work than simply saying, give me the whole thing and slap it down on the floor. And that's important. The opposite is true too. If I run the big broad date range first and then the narrow date range right afterwards, I got a clustered index scan, but I only wanted to return 169 rows. That's the wrong plan. And it took more reads than was necessary too. So the moral of the story here is that if you optimize your query for one set of parameters, and then your set of parameters change afterwards, you'll still reuse the same plan. And that may or may not be optimal. 99.9% of the time, it will be fine. But that 0.1% of the time, like what I illustrated here, is when things can go wrong. And it may not always be performance impacting, I mean, always be terrible, but this can lead to performance problems. This is what parameter sniffing is plan reuse gone wrong. I'll take a break here for a moment for a breath. I don't think I've breathed in like a half hour. Does anybody have any questions here before I continue?
There's no new questions in the chat at the moment, but if anybody does have any questions, while Ed takes a breath, has a little break before we get back into the demo. Yeah, deep breaths.
To breathe once in a while. That's nice.
Yeah,
I like that.
Just occasionally. Yeah,
just keeps you going, right? It's like coffee, but not as effective.
Exactly.
Whatever. All right, so we know what parameter sniffing is now. It's plan reuse gone wrong. Plan reuse is supposed to help us, and it usually helps us, but once in a while it fails us. This is how it fails us. So what do? How do we diagnose it? That's the first step to knowing we have a problem, is to identify it. And luckily, parameter sniffing is not hard to diagnose because it has telltale signs. Sometimes the most common symptoms are things that were fast are now slow, but you didn't change anything. Like no one changed any code, your proc didn't change, your code didn't change, your SQL didn't change, but somehow out of nowhere, things start running slowly. Maybe the use of this proc changed, even though the proc itself didn't change. Maybe it runs inconsistently. Sometimes they run this thing and it's super fast. Other times they have a spinning wheel on their screen for 10 seconds and they're mad. What's the difference? If you don't see a difference anywhere, it could be a sniffing issue. Sometimes it's simply obvious by looking at your proc. For example, say you have a store procedure that is humongous. It's 10,000 lines long. It has 40 parameters. It's very complicated. That's a great sign that you might have a sniffing issue, because the more complicated your queries are, the more complicated your proc is, the more complicated your parameters are, the harder it is for SQL Server to get the right plan all the time. And that means there's more of a probability that it could go wrong. If you have lots of branching logic, if, then, else, go to, whatever, go to, blah, 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 but if, then, else's, lots of case statements, switches, things like that, that branch your proc out, where sometimes you do this, sometimes you do this, sometimes you do this. That can lead to sniffing, because I optimized an execution plan for when I did this over here. I didn't do this at the time though. Now I'm doing this, and that plan for this doesn't make any sense. So a lot of branching logic can lead to it. So the real two ways to diagnose parameter sniffing are: one, inconsistent performance, poor performance with no obvious changes. That's kind of your first signal. And your second signal would be, look at your code. If your code is insanely complicated, branching, complex, messy, lots of parameters, switches, things like that, that's a great opportunity for sniffing to happen. And another fun way to know that you might have a sniffing issue is if you poke it and play with it and it just begins working for no reason. Like, it's broken, it's broken. Oh, I made a tiny change. I turned the exist to an in and now it's great. Oh, it's slow again. Oh, I added a no lock and now it's great. Oh, let me change it again. I'll do this and now it's great. If you're tweaking it and poking it and playing with it and it gets good and then bad and then good and then bad, it's probably sniffing and you're just tweaking. And again, the optimizer, when it has to pick out a query plan, is placing query costs on all these plans and picking one. And if you have two that are very close, this is a query cost of 10.1, this one's 10.2. As you play and adjust, you may just move them around a little. So it picks one instead of the other. But again, other things will change that later. So if you're poking with a stick a lot, getting changes, you're not really sure why, it could be a sniffing issue. The rest of the session is all about how do we resolve it? How do we deal with this problem? What are the good things we can do? What are the bad things we can do? What are the scary things we should do? What are the things that you just never, ever do at all, ever? And if you see it, get yourself a promotion by fixing it because it's crazy. Here we go. First off, we're going to start with the crazy because there's crazy out there. And I've seen every single thing in this presentation done in production environments many, many times. So this is not fantasy. This isn't me being silly or being condescending. This is real stuff that happens. People do it. And an important thing about this whole topic of sniffing in general is that if you go on the internet and use Google University to try to find out what to do, there's a lot of bad information. People will tell you to do some of these things to fix your problems, and they may or may not be the best solution. Be very, very cautious on using the internet for solutions on parameter sniffing, because the things that people say always solve their problems may have an asterisk next to them for reasons we're about to learn. Here's something I saw done once that really scared the heck out of me. Somebody took a whole bunch of production procs, they did one, and they had a sniffing issue. They decided to redeclare their parameters locally inside of the proc, and then they tested and it worked. And they were happy. So they then went out and they did it everywhere. They took dozens of stored procedures and they redeclared all the parameters locally inside of the proc, and then it fixed the problem. And they were happy and they went on with life and felt really great. But this is a cheating. This is hacking. We shouldn't do this, because what actually happens when you redeclare your parameters locally inside of a stored procedure, I'll demo it in a sec, you basically take away the optimizer's ability to do its job. Local variables cannot benefit from stats. Statistics are really important. They're all that data stored about your columns and your indexes to tell SQL Server, well, how many rows were in that? What are the values like inside of that column and that table? That's really valuable information for making a good decision. Should I do a seek or a scan? Should I do a merge or a hash? And so on and so forth. How do I do it? Once you do local variables, whether you're in a proc or not, stats don't really help much anymore. I can't use them, so it approximates. And the approximation is a very rough approximation. It's not a very good approximation. It's a very generic approximation. So therefore, as a result, you get a mediocre plan. Now, it's consistent. I'll give it that. It stinks all the time. It might be mediocre in the fact that it works. It won't be optimal. It might be good enough to fix a problem you have, but it won't be good long-term. I saw that thing in the chat just now about it being required, and that's really scary. So I'm glad that Hugo is as scared as I am, because this is scary stuff. The key to this is if you do this, it will haunt you. It'll come back in the future and either haunt you because you're the dev stuck dealing with this, or it'll haunt some person that comes after you who will see your initials and curse you and light things on fire in your name, and you'll be an evil person to them. So don't ever do this. This is a never. Some things in life are nevers. There's not very many alwayses and nevers out there. This is a never. How does it look to do this? Well, I create a stored procedure. I'm going to get my order details for a date range. I'm going to redeclare my variables locally. So here are my inputs, start date, end date. I'm going to say, hey, make new local variables, start date local, end date local. I'm going to assign start and end date to them. I'm then going to just go ahead and run my query with these local variables. It seems innocuous enough, right? I'm pretty sure this already exists, but I'll just check and make sure. It's already there. Great. So now I go ahead and I run my proc for a narrow range of dates. And I get an index scan. That's not right. All right, whatever. I run it for a wide range of dates. Oh, an index scan. That's what I wanted. Great. I run it for another range of dates that returns no data. I still have an index scan. That's weird. The moral of the story is it doesn't really matter what I put in for start and end date. This execution plan will be the exact same thing every single time, no matter what. I could put in imaginary numbers here, anything, it doesn't matter. It's going to be the same results over and over and over in terms of execution plan. Therefore, you might solve your problem temporarily in production and get back the plan that's good enough, maybe, but it's going to be the same plan over and over. It's going to be wrong a lot. And this is a ticking time bomb. This is what I call a time bomb in code. You'll do this, it'll fix your problem right now, and at some point in the future, it's going to break. And when it breaks, it's going to break badly. A lot of people see this, they do this, it fixes their problem, and then they do it everywhere. And now you're putting ticking time bombs everywhere. Just don't do this. Never redeclare variables locally. It's a bad idea. If you want to do hacks and tricks to get around a problem, there's better hacks to use. I will have for you better hacks later on. I still do not advise, tweaking your way out of a problem every single time with query hints and table hints. There's a danger to that, but avoid this one, please. As a side note, in case you don't know, when you use a table hint or a query hint in SQL Server, what it's doing is telling the optimizer what to do. It's essentially removing, so the optimizer runs off transformation rules. Every time it has to come up with execution plan, there's a whole big long set of transformation rules that it tests out to figure out how do I get from point A to point B to point C to point D to done. When you put in query hints, it removes transformation rules. So you're actually telling the optimizer, hey, just don't do it this way, don't do it this way, or do it this way. And you're basically telling it what to do, you're limiting its options, and therefore it could be good or it could be bad. Therefore, this stuff can be scary. Here's our next hack. So we don't want to ever do that. Just don't do it. Verdict, never, never done. Okay, great. We're not going to talk about redeclaring stuff locally ever again. We just don't do it, never. Next one, this is a little more useful. Option recompile. Again, it's a query hint, therefore don't spam it everywhere, please. But what does this do? This hint, when used, will cause your query to automatically generate a brand new execution plan every single time. It will not touch the plan cache. It will not alter an existing plan. So you can have plans over here for the same query where it doesn't use recompile, and that's fine. This is generally a good solution for a very, very parameter sensitive query that is not executed often. That's the key to this. If your query is run infrequently and has a known parameter sniffing issue that's very, very hard to get around, recompile could be a good temporary solution and maybe a permanent solution if you just can't find a way to solve it. The key, though, is infrequent, because what are you paying the price for? There's always a price to pay, right? With great power comes great responsibility. The price here to pay is compute. Every time I recompile the query, I've got to generate an execution plan. As I mentioned earlier, optimization is expensive. So if you optimize a query more often, you're spending more compute, and compute isn't free. It may be in Azure, but it ain't free. And if you begin recompiling too often, it may get expensive. Your monthly bill may get expensive. So don't use this in places where it's going to potentially get used very, very often. You don't want, this is for like the reporting query run once an hour. Perfect. For a query that runs 1 million times a minute, this is terrible. Let's just kind of demo this quickly. This is a good solution sometimes when you know what you're doing. Like all query hints, if you know what you're doing, it's great. We're going to clear out the cache in my database here. So here's an example again of a query. I run it, I get an execution plan, it gets saved in the cache. I can go ahead and look in my cache, and there's my execution plan. It got run twice. Awesome. Now, if I go here and I run this a few times with recompile, and I go back here again, I will see that my execution plan from earlier is still here. It got used twice, nothing changed, but it wasn't used again. Each time I ran this query, additional times with recompile, it made the optimizer do all of its work all over again. So it's more compute, but it does give you a good shot at getting the right plan. Sniffing is no longer an issue because I'm not reusing my plan. That's what recompile does. It is useful sometimes. It's useful sometimes, but only when appropriate, only when you know what you're doing, only on queries that execute infrequently and that will not get executed more in the future. A key to query hints is you put them in place, but you really have to know that the query patterns and application and business patterns that surround that query aren't going to change. If if another developer or some feature team says, hey, we're going to change the app now to use this code more often, and you have recompile in there, you're about to get in trouble. So make sure you really know what you're doing with query hints before you use them, because they might get you in trouble. And of course, cleaning up this mess for other people later can be a good opportunity to get paid and get a promotion, but it's not really the best way to go. You want to write good code. Don't write crazy stuff. So useful and appropriate, don't overuse. Thank you. How about into the weird world? So recompile is kind of useful. How about weird? This is another weird one. I've seen people who have taken and wrapped dozens and dozens of stored procedures in dynamic SQL because they thought, hey, it worked once, it'll work every time. This is great. So dynamic SQL, you're wondering, why am I talking about dynamic SQL here? Why would anybody do that? And the answer is that some people will take their complicated parameter sniffing query and they will wrap it in dynamic SQL and splice in the parameters into it to get a query that will then run kind of ad hoc-ish. This behaves similar to recompile for queries with different values. So if your values don't repeat very often, it's kind of like that. If your values repeat often, you will get more plan reuse, which is good. The real problem, though, with dynamic SQL, and I'll demo it in a second because it's just ridiculous, is it's confusing. No one's going to know why you're doing this, and it's going to be complicated. And because of that, the only real time you should do this is when you already really should be using dynamic SQL. If you have a good reason to use it already, use it. If you don't wrap all your stuff in dynamic SQL for the sake of performance, because it's complicated and it's going to make your code confusing. No one's going to know why you're doing what you're doing. And how does it look? Well, it looks like this. So I clear up my cache again. I create a proc where I now will I'll create a dynamic SQL command, big N varchar, and I will splice in start date, splice in end date. So my actual query that executes will have literals spliced in. They're not local variables, they're literals. They get spliced in for start date and end date. And I think this is already created. It is. And if I go ahead and I execute it for a narrow range of dates, I get my seek. Awesome. If I run it with a broad range, I get a scan. Great. If I run it for the imaginary set with no results, it's a seek. Great. If I go here and look at my plan cache, I will say I did get 3 separate plans. But if I go in and I just F5 these a whole bunch of times, I'm button mashing my keyboard, awesome. And I go back and I run this some more, I get 8 uses each. I'm going to answer that question in a sec, Hugo. That's a good question. The reason I get 8 uses is because I splice them in. There's a lot of reasons to not do this. SQL injection is one, Calvin, good point. I didn't parameterize dynamic SQL on purpose because when I've seen this done in production before, people have created dynamic SQL explicitly for the purpose of evading parameter sniffing. And this is kind of a funky use for it. And you're right, Calvin, SQL injection is a bad reason to do this. Another reason why this is dangerous. In general, wrapping your queries in dynamic SQL and executing them like this is dangerous. It's weird, it's hard to document, it's confusing, and you probably shouldn't do it. Those are great questions. It's weird. Is there echoing on the sound?
There's a little bit of echo, but
is anything I'm doing helping?
I mean, I can understand you loud and clear. So
I'm a little softer.
Yeah, it's a little bit less echo.
Okay, that's cool. So I appreciate the feedback. That's good to know. I don't want to be garbled and hard to understand because I do know that I talk a little speedily. I appreciate it. But dynamic SQL, wrap up on that is you probably shouldn't do it unless you have a great reason to already use dynamic SQL. And if you are, the comment from earlier is very important. You should parameterize it. You should protect from SQL injection. That's really important. So in general, don't do it. It's probably a trap. You're probably getting yourself in trouble. And again, especially if you do it everywhere. If you say, hey, I wrapped it in dynamic SQL, it got fast. Let me do this everywhere. You're falling for a trap. The moment you say, let me do it everywhere for the sake of performance, you're probably falling into a trap. Don't do it. Don't fall into traps. It ain't fun. All right, how else can we hack the system? Another query hint, optimize for. Optimize for is a query hint that will take, and you can put in specific parameter values, and it will optimize your query and make an execution plan for those values. This is very effective in fixing the queries that have local variables and weird problems and just stuff that's complicated. You're not really sure how to optimize it. But to make this work, you've got to know those parameter values to splice in there and use as your optimized for values. Therefore, you could have really good app knowledge, good business knowledge of what is this query, how does it work, will it change? And you may or may not have that. Like all query hints, don't use it everywhere. Don't spam it everywhere. The moment you begin slapping this down everywhere is the moment you're doomed to have a miserable career where everyone hates you and you hate yourself. And we don't want that. We want to be happy. And putting query hints everywhere blindly is going to make us unhappy. You'll make me unhappy, you unhappy, we'll all be sad. Let's not be sad. In general, this is something that's to be used very, very cautiously. And many of these query hints are things that you can use as a temporary solution while we find a better solution. How does this look? How does optimize for look? And again, these are things you can look for too. When you're out there investigating performance issues in SQL Server, you can look for these things that people have done. Has somebody redeclared the variables locally? Have they wrapped it in dynamic SQL? Did they use Recompile or optimize for? Those could all be things that lead you to the solution to a problem. It's very possible somebody tried to optimize a problem and in the process created a problem, and you're identifying it now. And now you have two problems, so the price is one to solve, which I guess that's enjoyable, right? So here's a proc that's going to get order details, and I've thrown in option, optimize for. So I've specifically gone in and said, hey, take this query, and when you execute it, make an execution plan for these parameter values, a nice narrow index seeky range. I'm forcing it. I'm telling it this is what I want you to be and how to optimize. It's already there. Great. So now, if I execute it for a narrow range, I get what I expect. If I execute it for a wide range, I get back a narrow range. Why? I told it how to execute my query. It has no choice. SQL Server has been fed exactly what to do here. I told it for these values. It does not care that I put in 2014 here. It doesn't care that I put in 2016 here. It doesn't care that I put in imaginary dates here that have no results. It could be 1920. It doesn't even matter. Whatever I put in gain the same execution plan because I forced the parameters to be optimized for this. So my results are correct, but my execution plan is going to be honed in for this. That's what optimize for is. And I'm going to say that it's almost definitely a trap. The only use case I've actually found for this personally where it was valid was a temporary solution. There was a production problem. They couldn't solve it. The server was teetering on the brink of collapse. Everybody is freaking out. Things are slow. Making this one change fixed everything. That is a valid use for a hack. This is a great time to hack something is when you're in deep trouble in production, things are breaking, you can fix it. But that also means you should go back later and put a permanent fix in, because if you don't, you're guilty. Then you're falling into the trap. This will come back and haunt you later. So really a lot of these query hints are great as temporary solutions. They're kind of lousy as permanent solutions. Here's a cool one. Became available later on in SQL Server, a temporary stored procedure. It's exactly what I say it is. You probably didn't even know you can do this. I didn't know I could do this until like 3 years ago. They're pretty cool. A temporary stored proc is exactly what it sounds like. You can take a stored procedure and create it with a pound sign in front. And that stored procedure is just like a temp table, temporary. You create it, you use it, and you can either drop it or end your session and it goes poof, just like a temp table. This is a great way, if you have temporary business logic that's important, to isolate it, create it, use it, and drop it. The beauty is that your execution plans have a limited duration. You create your temporary stored procedure, and while it exists, you get plan reuse, just like you want. But then you drop it. When you drop your stored procedure, all the plans go poof. Therefore, you can target code where you know you have sniffing problems, give it a temporary proc, optimize that proc, make it work correctly, and make it temporary. This is a good solution when you have very specific query patterns that change over time and you want to evolve with it. Or if you know you have specific scenarios where this area of code is encapsulated, it's kind of separate, and you don't want it to mix in with anything else. Like you have some proc that executes 1 million times a day. There's a specific use case over here in left field where it's always different. You know it. Make a temporary stored proc. Execute it, get your special plan, everything works great, done. And because it's temporary, you have full control over it. You can at any point in the future change it. You can make it permanent, you can get rid of it, you can do whatever you want. It gives you some flexibility, which is kind of nice. What does a temporary stored proc look like? Great question. It's exactly the same as before, except the pound sign in front. There you go. I did it. I put a pound sign in front. Did I already create this? No, I didn't. All right. Now I run my temporary store procedure and I get my results. I run it with a different value. I get results. I run it for a wide range. This behaves just like earlier. I have parameter sniffing and everything. So you can really treat this like a regular proc. But if I had a subset of use cases that were done occasionally, say, for example, I had a scenario where I ran a query all day long that got a little bit of data for orders and production, but then I had one time that it ran once an hour, it summarized a large volume of data for a report. I could put that in temporary proc or a separate proc. That's great. That's really what it's for. And I can drop it because it's temporary or just end my session. Doesn't really matter. It'll go poof. Temporary store procs are cool. You're probably not going to use them very often, but it is a nice way to isolate specific use cases into their own world and not build permanent objects to manage them. It could be good for like a release, for example. You have a software release. We've got to use a special proc as part of the release for a couple hours, and it goes poof. Don't got to create a permanent one. You can make it temporary. Can other sessions call a temporary store procedure that you create? And the answer is no. The answer is that it's just like a temporary table. It's available in your session. If you go outside of your session, it's not usable. And the real benefit of it over the recompile hint is that you can control its usage. Recompile goes in your query, now it's a part of your query forever for any use case that might use it. But your temporary store proc can be saved over here in left field and used for individual use cases. So it's not really a benefit or drawback. It's really how you use it. Oh, can you make a global temporary stored procedure? I don't know. It's a good question. I think you can. Can you? Yes. The answer is yes. So I wasn't 100%, but I was pretty sure. Good question. And in general, I advise against making global temp tables, global stored procedures, global anything, only because they don't have security. So if you create a global temp table or stored proc, anybody can access it regardless of their access to SQL Server. So I could be a plebeian with no access to anything, and I can get to your global stored proc or global temp table. So in general, I avoid making global temp tables unless you really know what you're doing, because security does not apply. If it doesn't matter to you, if security is not an issue, go for it. But if you have a public facing server where everyone's getting into it, global things will get you in trouble potentially. So to kind of summarize, the temporary stored procedures, useful in rare moderation. They're a specific unique use case for a temporary business logic, or specific use cases that are kind of unique that you don't want to persist as schema in your database to get reused elsewhere. All right, let's get crazier. I've mentioned any trace flags yet. I'll throw a trace flag out. Why the heck not? Trace flag 4136. What does it do? It disables parameter sniffing. Sounds great, right? No more parameter sniffing. It's gone. Never again. But that's not really what happens. This does not disable parameter sniffing. What it actually does is it essentially is optimizing for unknown by getting rid of plan reuse as we know it. Therefore, you're now getting a rough estimate server-wide for all your queries. That's probably a bad idea in general. You probably don't want to do this. Setting a trace flag like this means that you have a very specific server with specific use cases where you really know this is the right thing to do all the time, always. You can tell your manager, the CTO, the CEO, whoever, the president of America, whatever. You can tell them, this is the right thing to do always. I believe in it. Here's my rubber stamp of approval. If you can't do that, don't do this. Trace flags are a little dangerous. You got to know what you're doing. You've got to really know what you're doing. In general, I advise against this. If you need to go disabling sniffing for some reason, do it on a query by query basis. Don't do it server wide, again, unless you 100% know what you're doing and can attest to anybody that you mean it. So I won't even demo this. You probably shouldn't do it. But if you have a server behaving really funny, not a bad thing to check for. What are the trace flags running currently? Is 4136 running? Oh, it is. Maybe I don't want this. Cool, fix it. Can you find a temporary store procedures plan in a plan cache? Yeah, plan cache. Yes, you can. A temporary store procedure is just like a store procedure, but you'll find its plan in tempdb, not in the database. If you're in database AdventureWorks and you create a temporary stored procedure, it'll be in tempdb. So you just go to tempdb to get the plans and all the information because it's where it's stored. Just like a temp table. Temp table stored in tempdb, which is a database, not a memory on disk. You can therefore look at the data there and understand it. Oops. All right. Let's continue. Here's where I spend a little bit of time. This is what you've all been waiting for. This is the part of the presentation where I tell you that your code probably stinks a little. And not just your code, my code, your code, everyone's code. We've all written bad code before. We've also all written code that was good and became not good with time. Things changed, stuff happens. I'm not blaming you. I'm just saying this is how code goes. Code gets bigger and more complicated with time. I alluded earlier on in the session that there are certain ways to identify parameter sniffing, and one way is to look for weird code, look for complicated code, lots of branching logic, very long stored procedures, and we're all responsible for these. I am right now. I have procs I'm responsible for that have 15,000 lines of code. I know they're time bombs. I know they stink, but at least I know that, and that's useful. One of the best ways to really get rid of sniffing issues when you see this is to simplify your code. Very often, parameter sniffing can be caused by bad code or ill thought out code or code that got big over time. Code paths are huge. Imagine in your mind, you have a stored procedure with many code paths. If, then, else, if, then, else, if, then, else, else. Go to, case, while, whatever. All of this branching logic makes it so when you create an execution plan, it's going to think really hard. Like, which way do I go? Like this way, this way. What do I do? How do I get one plan that encompasses all these decisions? And the answer is you can't really. It picks a plan for all those decisions, but it's kind of arbitrary. And if future decisions go this way instead of this way, it may not be the right plan anymore. If you see a stored procedure that has many code paths, lots of branching logic, and you know the sniffing is a problem and it's biting you, your best solution is to break that big proc into smaller procs, because in each individual stored procedure will have a smaller piece of code, simpler code, less branching. Therefore, you're more likely to get a good plan every time. This is especially important for the multi-purpose procs. I've seen many of these before. You might have as well. You have a stored procedure with some flag or use case for a bit that gets passed in, or an int gets passed in that says, if it's 0, do this. If it's 1, do this. If it's 2, do this. If it's 3, do this. And depending on that bit that's passed in, or that parameter that's passed in, that value, you do a whole different piece of code. Well, that's destined for sniffing, because I've now made a plan for a proc that does this, and sometimes this, and sometimes this, and sometimes this. It's never going to be right all the time. It's going to be wrong. It's going to be weird. That's a great scenario for taking that proc that does 5 unique things and just make it into 5 procs. I know that making more procs sounds weird, but it's not a bad thing. More procs isn't bad. It's better than sniffing. It also simplifies your code. So now instead of having to alter a 15,000 line monstrosity whenever things change in it, you can modify a smaller proc and leave the rest alone. Again, optimization is a game of complexity. The more tables you have, the more joins you have, the more filters, the more aggregate, the more things that you do in your query, the harder it is to for the optimizer to get the correct plan. The more complicated it is. It's got to play a chess master game to figure out what's the best chess move. And the more options it has, the harder it is. The more parameters your proc has, the harder it is. If you've got a proc with 50 parameters, it's really hard to get the one magic plan for all those parameters because they change so much. Too many parameters is, again, a chance to think, what can I do to get rid of some parameters? Are some of them automatic? Do I not need some of them? Can I break this into smaller pieces? Can I make assumptions? Can I derive this one from this one automatically? Like, is this always 2 times that, or is this always 4 hours after that? Can you do that instead? Less parameters is generally better. You don't have to reduce the number of parameters you have to get a good plan. But if you see a proc is having problems and it has 70 parameters, you might have a parameter problem. That's all. And again, it's a chance to either move business logic out of triggers and procs and scary SQL into code. Simplify your code, split it into smaller pieces logically. Again, business logic in the database happens all the time. It's hard to avoid, but too much of it makes your SQL complicated. And then optimization is hard. Another reason for sniffing to happen is you stepped on your own feet. You tried really hard to optimize over and over and over and fix things. Query hints and width and optimize for and trace flags and dynamic SQL and local variables. And you messed around a whole bunch, and now you're having more performance problems. Hacking around too much to fix a problem creates more problems. It's better to not hack if you don't have to. And kind of the last general scenario for how you can get rid of sniffing is to look at your overall use case. What is my code doing? How's my SQL Server data structures? How are they architected? And am I making weird decisions? Like, for example, am I running analytic queries against a transactional database? Am I running transactional queries against an analytic database? Am I trying to use a table as a queue and I'm constantly pushing and popping things on and off and on and off and on and off, and and doing that kind of thing? It's very, very churn heavy and hard to work with. Lots and lots of contention and so on. Am I really just doing the wrong thing? Is there a better way to do what I'm doing? If the answer is yes, do it the better way and then circle back when you're done and see if I got rid of my sniffing issue. This really is the biggie though. At the end of the day, we want to write the best code possible, and odds are very, very good 99% of the time, sniffing issues can be solved with improving our code. It doesn't feel very good. We love blaming SQL Server. It's a wonderful feeling. We can just say, add a hint and it's all fixed, right? One index and it's fixed, but that isn't always a solution. So keep in mind that most sniffing issues are code issues, and they can be fixed by making our code better. And when you do so, you fix the problem forever. It won't come back and haunt you in the future. It's fixed forever. Somebody Chad commented here. Too many triggers, deprecated data types. Sure. Old stuff, legacy stuff. Too many triggers is always scary because now you're updating a row and a million things happen every time that might be iterative, that might not be the way you want them to be. So great comments. I appreciate it. 100% things that can cause bad issues. Forced parameterization. I'm going to come back to that in one moment. I see what you said. I'm going to talk about it soon, I promise. To kind of circle back on the better code, service broker, the queue nobody ever uses. It's true. It's true. It is a good solution. Improving your code is generally the best thing you can do to make parameter sniffing go away and improve plan reuse. It's hard. It takes some work. It requires understanding your code, which isn't always easy. Understanding the business use cases. Why am I doing what I'm doing? But it's the best solution, and it'll be the most permanent solution. There's more hacks out there. I'll mention one of them because it was already mentioned here. So I'll go to forced parameterization first. You can do a database configuration, which in some cases is very useful. Set parameterization forced. This essentially takes ad hoc queries that are not parameterized and tries to parameterize them and then reuse plans. They will go in the cache. You will see them in there. And that is generally not a bad thing for databases that have lots of ad hoc queries. In general, I would say when you're trying to check for parameter sniffing on forced parameterization scenarios, apply basically the same rules we applied here. And the biggest enemy you'll probably have is going to be code complexity. You're running ad hoc queries. It could be coming out of an ORM or something like that. How complicated are they? And if they're really, really complicated, what can we do to simplify them? Are there too many joins, too many filters, too many group bys? Is it just grabbing too many columns? What is it doing that's so complicated that's making it because in of itself, forced parameterization is not going to break anything. It's really just trying to use plans more often on queries that normally wouldn't. They're not encapsulated in stored procedures. So what else is going on? And so the answer is take a subset of what we talked about and apply it to the conversation and hopefully find a solution. If you have some really interesting sniffing issue that you can't diagnose, feel free to send it my way too. I'll happily take a look. I like seeing interesting challenges. Other things you can do to hack around. There's a query hint, disable parameter sniffing. Wow. It gets rid of parameter sniffing. Yay, it's the worst named query hint ever, and you probably shouldn't use it. Why? It's optimized for unknown, and optimized for unknown says make a rough guess and run with it. Sounds great, but it generally means that you get a mediocre plan all the time. Mediocre might be good enough sometimes, but as we all know in life, if somebody asks you, how good of a job did you do? How are you at your job? How good are you at this? Do you like this? The word mediocre generally is not the word you want to use to describe your quality of work. This is kind of a mediocre choice. It'll be good sometimes, cruddy most of the time. usually a bad idea. So like earlier, disable parameter sniffing sounds cool, but you probably shouldn't do it. I can display it here. So let's create a stored procedure where I go and do my search and I use the special hint, disable parameter sniffing. Yay. It's not a yay. I'm kidding. Don't do this, please, much. It's already there. Oh, it's not there yet. Great. So I created it. I've disabled parameter sniffing. What does that mean? I run it. I get a scan. That was a narrow range. I run it for a wide range. Scan. No results. Scan. More no results. Scan. Doesn't really matter, does it? And the answer is making a rough guess, and the rough guess says scan the table. And that's right one time for this use case here. It's wrong for all the rest. So disable parameter sniffing is probably a bad idea. It's telling the optimizer to stop using most of what it uses to get a good plan, and it's not going to do plan reuse. So it's kind of bad. It's a very rough estimate, and rough estimates are bad. Probably don't want to do it. You get a lot of garbage plans. It's not really what you want. Another random thing, optimize for ad hoc workloads. This is another scenario where it's trying to not cache. This is great for servers. We have a lot of ad hoc workloads where you may not want to cache your plan because there's a lot of queries that run once and never again. Optimize for ad hoc workloads is a way to help with plan cache bloat. So you have queries that come through once and never again. What do? What happens here, you turn this option on, SQL Server will not cache execution plans for the first execution of the query. It'll save the query hash. It'll save a stub of the query with a little bit of information. And only later, if run more times, will it generate a full plan and use it. This is specifically meant for scenarios where a server gets lots of ad hoc plans and only some things get reused. For example, you have a server that's targeted with an ORM. ORM is always running ad hoc queries all the time, never reused ever. Well, if that's the case, ad hoc workloads is great. And then when procs do get reused over and over, this will happen instead. This is not good everywhere. Turn this on everywhere is not a great idea, but it is a great idea for specific scenarios where your SQL Server has lots of ad hoc workloads and some reused things. Again, use it when you need to. Don't use it everywhere. There's many more hacks out there. The internet will have lots and lots of suggestions for ways to hack your way around sniffing issues. These are some. Some of these are good. Some of these are bad. Some of these are useful sometimes. But I highly recommend don't overuse any one solution because it will lead you into trouble. I'm enjoying the comments here as well right now. Lots of interesting stuff. ORMs equal lots of compute. Yep. For anybody who doesn't know, ORMs, they are basically all of the many tools that generate SQL for you. They're the entity framework kind of things. They're the nhibernates and so on. And they go out and they say, give me all the details about your objects and we'll generate queries for you. So a machine's generating queries for you instead of you. And the result is often the queries could be good, they could be bad, they could be anything, but a person's not doing it. Therefore, the ability to respond to them can be limited. There are some things here that help. Optimize for ad hoc workloads could be a great way to deal with it. But in general, your options are limited because ORM does all the work. If it's smart, it'll make things that are reusable. If it's not, it'll all be ad hoc. This is where you talk to your architects and say, hey, we want to chat about the code that your computers are generating and what can we do about it. So they aren't necessarily bad, though I suspect that many people do think they're evil. They aren't necessarily bad, but they're dangerous. They create SQL that's out of our control. I think that if you're a SQL Server or database administrator, you love stored procedures and functions and things where you can encapsulate your code and manage it. If you're a developer, you like to be able to write code and do whatever you want to do. If you're an architect, you love handing it off to an ORM and not worrying about it. So it really depends. All right. We'll do some cleanup here of all the procs that I created, though I'm happy to recreate and demo things some more after this. The real key to this whole discussion here, to kind of wrap up, I want to have time for questions and discussion. Plan reuse is a really important part of SQL Server. It's not a hack. Parameter sniffing is not an evil thing. You should not avoid it. This is a very important part of SQL Server. If you do not have plan reuse, it would be really bad. Your server would be pegged at high CPU all the time, especially if you're a very busy production server. Having to run queries over and over and over the plan reuse would be very, very expensive. So keep that in mind if you use recompiles and trying to get rid of parameter sniffing and things like that. Plan reuse is very important. And 99.9% of the time, it will do exactly what you want it to do correctly, and you'll be happy. And you won't notice it in those scenarios. When it's behaving correctly, you won't think about it, you won't talk about it, it won't give you a hard time, but it's there and it's important. When there is a sniffing issue, when things aren't working correctly, that should be seen as an exception, an outlier. Deal with those things separately, and when you deal with them, keep those solutions separate. Don't say, hey, I found the solution to sniffing, and I'll apply it everywhere. Because odds are very good you're going to take that solution, put it everywhere, and create a mess for some future you to deal with. And you don't want that, and no one else wants that either. So never reuse one solution everywhere for any reason. I've seen it done too many times. I've seen in production environments, dynamic SQL everywhere, redeclared local variables everywhere, recompile everywhere, optimize for unknown everywhere. And when I say everywhere, I mean all over the place. And I'm not joking, I'm not being sarcastic. And this stuff scares me because you're taking a specific solution and applying it to everything. That's not how it works. If you've got a problem in one place, don't apply the solution everywhere because you don't know if it's going to solve it or not. You just don't. So use it where you need to, and don't do it elsewhere unless you have to. If you create hacks to make your problems go away, get rid of the hack later. That should always be part of a fix, because I know many hacks go into production or somewhere because you have an immediate problem, it's dangerous, it's bad, you gotta solve it right now, you don't have time, and you know that this one hack will fix it. That is okay, but go back and fix it later and get rid of it, because the hacks will come back and haunt you later because they're hacks. They're not meant to be permanent. And every time you tell the optimizer what to do with some query hint, you're hobbling it a bit. And the more you hobble it, the more likely it is to be hobbled in the future and not do what you want. And because of all that, improving your code and your business logic, your T-SQL, really is the optimal way to deal with this problem. And it's not the easiest. No one likes fixing code, but it's the best way to solve problems. That's your question. Do you ever write sprocs with branching logic to run slightly different versions of a query? I've done that in the reporting world a lot, honestly, like in analytics, when these queries are big and chunky and they're churning through mountains of data. I'll often do that. And I find that the execution plans tend to be the same regardless, because I'm crunching a mountain of data. And a mountain of data in a column store index in some giant analytic world is going to execute very similarly each time. I would beware though. Beware with branching logic. You can use it. I think that if you're going to use it and you're confident of it, just be aware of it and what can happen. That way, if there is a sniffing issue, you immediately recognize, oh, I have 5 branches here, and this one branch is the breaker. I do see this a lot too. Sometimes people will write a query that has unions in it. Select a bunch of stuff, union all. Select a bunch of stuff, union all. Select some more stuff, union all. One giant query, lots of unions, and one chunk of that query performs terribly, but the rest is good. And sometimes breaking your big thing into smaller pieces will help, whether it's your branching logic proc that has 10 different sections, depending on which branch you choose, or the union all-togethers. If you've got a proc or a query that does a bunch of stuff in one, it's the all-in-one, and it's performing poorly, test each section and see which one's performing poorly. And if you find that one section performs badly, splice it out into a new query or proc and handle it separately. I'm not advocating you split everything into a separate proc. I'm not advocating you rewrite all your code. I'm not a jerk. I'm not going to tell you to do that. It's not very nice. But when there's problems, then you should consider getting at least the bad piece out. If you've hurt your finger and you have an infection, you don't rip every finger off your hand. You just fix the one finger and you get rid of the infection with an antibiotic and you're done. You don't do it to every finger. You just do it to one. That's how it works. This is no different than database world. If you found an ingrown stored procedure, it's a little gross, it's a little yucky, you poke it, it hurts. Find the one piece responsible and fix it and leave the rest alone. That was kind of gross, actually, wasn't it? Sorry. Well, it was the best analogy I came up off the top of my head, so you get what you get, I guess. But yeah, I think the comment here from Elijah is very true. Branching logic is kind of used as a band-aid in bad database design. I often find that it's also used as a way to take and add functionality to an existing thing without having to alter code. If your code uses a proc and you alter the contents of the proc without touching the inputs and outputs or the code, then developer don't have to do any more work in the database. Database is going to change, but your code doesn't change, which is convenient. Sometimes the benefit code-wise to not having to change things here, but it can get unmaintainable if your thing gets bigger and bigger and bigger because you keep adding sections and sections and sections. And then one day you've got a proc with like 100 sections of code in it, and it's very complicated. And I've seen them many times. You've probably seen them too. And that gets messy and complicated. And if you get to a point where you've got to like spend 20 minutes staring at a proc to know what it does, it's probably gotten too big and complicated. I'm not going to say your code should be self-documenting. That's just kind of like, a name drop to an idea. But it shouldn't be so complicated that you require days of research to get it. It shouldn't require churning through tens of thousands of lines of SQL to get it. That means you've done too much in one place. I think at this point, this would be a great place to stop and take some questions. If there's questions, I'll be happy to discuss or answer them or just have a talk. If there are no questions, I will meander off into similar ideas and talk about other things related to what we've been discussing. But I don't want it to stop. I'd love to hear what you have to say because this is kind of, a group thing. So questions, ideas, thoughts?
Well, I think it'd be good to kick off this section with thanks from Bryce for the fantastic presentation. And yeah, thank you, me as well. I learned a lot today too.
You're welcome,
I'm sure everybody else here did. Scott said thanks out as well. Yeah, so if you've got questions, drop them in. But yeah, there's lots of love coming your way at the moment as well. So thank you.
Cool. Well, thank you. I appreciate the call out for database design. That's huge. Doing something right the first time is way better than fixing it later. And I find, especially in small organizations that don't have the resources to do everything, that step gets skipped a lot. Like you have a developer, they develop code, and then it gets QA, it gets deployed, and you never get the design step. But there's a benefit to taking a few minutes, whether it's a formal design process or kind of an ad hoc one. There's a huge benefit to taking time and doing a little bit of thinking on how will I design and architect these database objects, these data structures. What data types should I use? Should it be a proc? Should it be a function? What kind of indexing should it use? There's many options you have. Take a little bit of time just to brainstorm and think about it before you build them, because it's very easy to do the wrong thing and the wrong decisions can hurt. I have seen legitimate systems where a date was stored as a varchar 8. And it was like 08262013, and that was your date, a string. And you may have done that for a reason, but whatever the reason was, probably didn't scale very well with time. And then one day later, you're like, let me get all my orders from a certain date in 2019. Why is it so slow? I can't get what I want. And you spend a lot of time. So think about those things. And it never hurts to ask questions. If you're doing something and you're not 100% sure what to do, ask somebody for a hand. It won't be hard to get an answer, and that one answer can help you make the right choice and then make the right choice in the future. It's one of those, tech debt is expensive, but no one realizes it up front. Everyone learns it later. I could have spent a half hour here making a good decision, but instead I'll spend 5 hours a week for the rest of my life fixing a problem. That sounds worse to me. That's just me. It happens a lot.
I don't think it's just you.
Perhaps a demo on how to find, after performance gets worse, what specific values were sniffed for a parameter or parameters. Great question. I can't really demo it right now easily given our time constraints, but what I will say is this, is that when you're looking at your execution plan, you can get detailed information about the parameters. If you run extended events, you can get detailed information with the values that were passed in. So that detail is available. If you have query store enabled, that is a great way to also get information on parameters, and it can follow parameter sensitive plans too. So query store is a great tool. I didn't really talk about it today very much. It's kind of its own separate universe, but if you have a version of SQL Server that has query store, and if you can use query store, consider testing it. I don't always advocate for using it in production. It can be a little heavy sometimes, but if you can do it, do it. If not, at least put it into a test environment where you can really hammer on it and test it. Query store is a great way to test parameter values, see which values are being used that are good or bad, and it can even auto-tune it. Query store can automatically manage like plans that regress and get worse. It's a great, great tool. And I'm glad you mentioned, demos on it, because there are many other tools out there. And there's third-party tools too out there from many vendors that sponsor our events that can 100% help you out. I'll name drop query store because it's internal to SQL Server. It's a great tool. There are many tools that will help us out there as well. So you're not on your own. All the suggestions I gave here were pretty much if you want to solve this problem yourself, what are my thoughts before you go off and get help? Because if you solve a problem quickly, that's wonderful. If you can't, begin branching off and looking elsewhere and testing. there's always that chance to bring the data here and test on it and play it and get a good solution. But I do appreciate the question. It's a great call out. I really do appreciate it. Are there any other questions in our last 10 minutes here?
Yes, got 10 minutes more of Ed. Well, I mean, you can hit Ed up on Twitter.
I'm not going anywhere. It's cool.
Yeah, I should say for anybody that joined a little bit later, if you do want the slides or any of the code and everything, then Ed, you've said get in touch via Twitter or email.
It'll be posted on Twitter as soon as I'm done here. Promise.
Lovely.
And if you do come up
all the sessions will be posted on GroupBy's YouTube channel as well.
Great. If you do have any questions later on too, feel free to let me know. In the meantime, we have a few minutes to discuss here, and I'd be happy to talk about more on this discussion, more on this topic. I'm kind of curious if anybody here has any experience with parameter sniffing. Any good experiences, bad experiences, funny experiences?
Yeah, it definitely seems like quite a few people in the chat have had some experiences, good, bad, the in-between as well. So yeah, drop those in there.
Oh, I see a mention here to subprocs. I missed that before. This is a fun one. I've talked about parameter sniffing very much as like you have a proc, you have a query, here's what happens. But what happens when a proc calls a proc calls a proc? The answer is you get nested logic and it's complicated. At the end of the day, you get an execution plan per object, and that's how it goes in the plan. The danger, of course, is that the more complicated it is, the more chance there is for sniffing because you have more ways things can happen. So really at the end of the day, the danger is just that you're going to have things that can be complicated and may require simplification. I highly recommend don't have procs calling procs calling procs, don't have views calling views calling, don't have triggers calling triggers calling triggers, because it's just complicated. And the more complicated it is, the harder it is to get a good execution plan. Harder it is to get an execution plan, the more likely you are to fail. And by failure, I mean sniffing, bad plans, whatever. And we can avoid them by simplifying our code. Question here about what do you do about handling heavy use of ORMs? And the answer is you're limited a little bit. A lot of people feel like their hands are tied because they're not using stored procedures. The one question to always ask is, will their ORMs support stored procedures? Will they support views? A view can be a nice question. Again, views calling views calling views, dangerous, scary. Don't overdo it. But I've found there's really two solutions in the ORM world. There's really three solutions, I guess. Solution one is indexing. If you have an index that will help and solve an ORM problem and doesn't put you to the territory of I've over-indexed my table, consider it. That's great. It's an easy solution. Sometimes indexing helps, especially for very common use cases that are used over and over and over. Optimize for ad hoc workloads is a great choice for ORMs where the queries are always different. If your ORM is putting in different queries and they're always different and they're never using plans, Optimize for ad hoc will help you because that will do the whole plan stub thing, the query stub thing, and it won't create plans for the second execution. That is kind of a nice way to do it. Views are a cool trick too. ORMs are kind of funky with procs and functions and things, but they are often pretty friendly towards views. So most ORMs, a view is kind of like a table. It has inputs, it has outputs, and you can use it like a table kind of. The beauty of a view is that you can then define it. Your view can be defined by you. You can create it, alter it, change it, do whatever you want with it. And you can control that as an administrator or an architect. That's huge. So now you have control over your code. So I would say that really the three ways to kind of look at ORMs are indexing, ad hoc workloads, and any kind of tweaks and hacks and optimizations for ad hoc workloads, or views. Again, I really advise against overusing nested views, but a single layer view that can replace tables and provide a better query for the ORM to use is a great solution where you're kind of compromising. They don't have to change the code very much, and you get control over what you're doing. And so you're not at the behest of the ORM anymore. That's a very good question. There are other tricks out there for ORMs too that you pick up based on your ORM. Every ORM is different. Some will do all left joins, some will do all inner joins, some will do only ins and not exists. They're all weird. They all have their own special patterns and anti-patterns that make them funky. If you run into them, customize your approach towards the ORM and kind of build a toolbox for it. It's a hassle, but there is a solution available as long as they're willing to do something. Even if the view, which isn't always ideal, but it could be a good way to do it. I would suggest synonyms too if you're desperate. Synonyms are a little more obfuscated. They're taking your code and saying, hey, point there instead. I'm hesitant towards using aliases and synonyms. You can use them, just hesitant because you're introducing complexity. But again, as a more temporary solution, when things are breaking, totally cool. Are there any more questions or anything you want to expand on with regards to ORMs now that we're all talking about the devil here?
Yeah, there've been a couple of comments where people aren't super fond of ORMs. Patrick, in fact, said ORMs are evil. So
I will not go so far as to call them evil, but I will say that one of the challenges of ORMs is that a lot of times they're put into place and used, and they don't get updated very often. And so they get implemented, and then they sit and they keep getting used, but they don't get updated. So you implement it in 2018, and then something's 2022, we're using the same RM. It's now 2026, using the same RM. And as technology advances, as our data structures advance, as our code advances, the RM kind of stays the same. A recommendation I would push back sometimes towards development teams or architecture teams use RMs is get more information. Ask them, hey, what version of the ORM are you using? Can you tell me some more about it? Can you tell me how you're using it? Can you show me the code you're using in the ORM? And it may very well be possible that you'll find a solution for them, like, hey, you should probably update 17 versions, if you haven't done that in a while. Or, hey, if you just use it this way, it'll make better code, because that might be possible. Not everyone uses an ORM correctly. It's a tool. And as mentioned somewhere further up in the chat by somebody wise.
Hugo.
Hugo. Thank you, Hugo. As somebody once said, Hugo, I'm going to use that again later. You can use a tool correctly, or you can use it incorrectly. And if you use it incorrectly, you know, bad things happen. There was one time I was trying to get an air filter out of a dehumidifier, and I couldn't get it. So I grabbed a hammer, and I grabbed the back of the hammer, and I took that backward section and I ripped at it, thinking, this will solve the problem. Let me rip it out. Well, the answer was a new dehumidifier, but it was old. It probably had it coming, right? But the wrong tool for the job, you're going to have problems, right? It's kind of the same thing. And yeah, sometimes people, as Lars suggests here, can use ORMs heavily, run into bad performance, may begin saying, hey, there's a problem here. We can't fix it. The SQL stinks. The performance stinks. Let's get out of SQL Server. We'll put it to Postgres. We'll put it into Mongo or Mariah. We'll put it into Aurora. We'll put it into Azure. We'll put it into AWS. We'll put it somewhere else. Because, you know, putting your data somewhere else will fix it automatically, right? And it might be the right choice, but very often moving your data for no good reason is a bad reason to move your data. So if you rely very heavily on ORMs, I highly recommend investigating the ORM more, take some time, dig into the details, even if it seems yucky, and learn how they use it, why they use it, what are the versions, what's the code like, what's the framework like, and then use that knowledge to better give advice, because it very well could be they're misusing the tool. And they just tweak it a little bit, they can use it correctly, and then your job is easy. Then you can curse them less, which is nice. We all want to sleep more at night. We want to be happier. We want to drink a little less sometimes, just, you know, a little. Don't want our jobs to drive us crazy. It's a good way to do it.
Yeah, less cursing at the end of the day.
Yep, you got it. I have to mute myself. Hang on. All right, I'm all good now.
Oh, we've got 2 minutes left for questions to Ed. Any other last minute questions? Sorry, Ed.
It's all good. You're saying the same thing I would have said.
Oh, wow. If there aren't
hit
any
the end of the
questions,
line.
I think
I haven't
possibly
breathed in an hour and a half.
Yeah, take a few breaths. Well, yeah, and just to say thank you again, Chad, thank you. Yeah, thank you, Ed, for a great session. I think very, very valuable, lots and lots of information in there for everybody, and some great questions and great chat going on. So yeah, thank you.
And thank you very much for having me today. I really appreciate it. I enjoyed this. I will post lots of things later, I promise. And if anybody has any questions beyond this, feel free to hit me up online anytime you want. I love discussing data. It's like my nerdy thing. So I'll be happy to talk about it. I won't be bored or offended, I promise.
Good. And you're in good company, I think. Yeah, and this is just the beginning of GroupBy. So thank you for kicking us off. Yeah, there's lots more great sessions today and tomorrow. So there's the rest of GroupBy Americas today. We've got an hour-long break now, just to let everybody know. So hop off, take a few breaths, grab a coffee, grab some lunch, and yeah, meet back here in an hour for Jared's session. Every millisecond counts.
Thank you very much.
Yeah, thank you all very much. And thank you, Ed, again. Great
Hopefully
session.
to see everyone here soon.
Yeah, see you all for the next one.